All right, we're gonna round out our lesson with a lovely little word problem. We love these real life examples. We're gonna see how to use a scale factor to help us find length and then also area. So a blueprint for a new library uses a scale factor of 1/50th, 1 over 50. Mr. Ayer measures the reading space on the blueprint to find the actual dimensions and area so he can order furniture. So part A, what are the actual dimensions of the reading space? So, we have our blueprint. This is on paper. This is representing to scale the real life reading space, like an actual reading space, a room. So what we're going to do is we are going to let X equal the actual length of the reading room. We're going to let Y equal the actual width of the reading room. So that means I want to say in real life. I mean, this blueprint is in real life too, but hopefully that kind of makes sense. One thing that's kind of hard to see on your copy, your paper, is that in our blueprint, from here, oh, don't use blue, we can't even see that. From here to here is 14 centimeters, and from here to here is 12 centimeters. So this is the length of our blueprint. This is the width of our blueprint. So what we're going to do is we're going to set up a ratio of the image side length. This is what we're calling the image right here, because it's a blueprint. It is an actual image of the image side length to the actual side length. So let's just make a note. The ratio of the image side length to the, whoa, what is that word? Actual side length is 1 to 50. So we're going to work with that 1 to 50. We're going to say 1 over 50, and then let's just make a note. This 1 represents the blueprint image. This 50 represents the actual room. We're going to set that equal to, let's work with the actual length right now. We don't know what the actual length is, but we know that the length, I guess we're going to work with length, and then we'll set up a proportion for width. So for our length, the length in the image we know is 14 centimeters. So I'm going to match my scale factor over here. Because the scale factor has a measurement for the image in the numerator, I'm going to put my measurement for the image in the numerator. We want that to match going across. Over, we have the actual length, and we don't know what the actual length is. So we're going to put, that's our X right there. X is the actual length of the room. And now we can just solve this proportion. We will cross multiply to solve this. So we'll just take 1 times X, which is X. We always put an equal sign in between when we cross multiply. 50 times 14. And we get X equals 700. And this is 700 centimeters. Just so you know, this unit is in centimeters. It doesn't say anywhere that it's in centimeters, but I'm just telling you, we got centimeters right here. All right, so X, the actual length of the room, is 700 centimeters. Now let's set up the same thing for the width. We're going to take our scale factor 1 over 50. We know that the width of our image in our blueprint is 12. So we're going to put that across from the image width of 1, excuse me. What we don't know is the actual width, and that's our y. I meant to put over here, that is the actual measurement. Okay, now we can cross multiply. 1 times y is y equals, cross multiply the other way, 50 times 12. Our actual width in the real room, the full size room, is 600 centimeters. So we were asked to find the actual dimensions. So the actual dimensions are 700 centimeters. And then if that just helps, that is 7 meters. So that's kind of an easier measurement for us to think of. 700 centimeters or 7 meters long, and 600 centimeters or 6 meters wide. All right, so we found the actual length and width. Last question is, what is the actual area of the reading space? Well, area, this is a rectangular reading space. Area is equal to length times width. We just figured out that the length is 700 centimeters. The width is 600 centimeters. If we multiply that out, we get 420,000 centimeters squared, because it's an area measurement. Or if we were to work in the meters, area equals length times width. If we use those meter measurements, we had 7 meters by 6 meters for the length and width, and we get 42 meters squared. So that is the actual area. How does the actual area relate to the area on the blueprint? Well, why don't we find the area on the blueprint? That is still length times width, but our blueprint, those were the image measurements. Our length was 14 and our width was 12. We multiply those out, we get 168 centimeters squared. So how does it relate to the area of the actual reading space? Because this unit is in centimeters, that's why it's helpful to have our area in centimeters so we can actually compare the same units. So what we can do to kind of make that comparison or show how they relate is if we take the actual area, 420,000 centimeters squared, divide it by the blueprint area, 168, we get 2,500. So what that means is the area of the actual reading space is 2,500 times the area of the blueprint. So the area of the actual reading space is 2,500 times the area of the blueprint.